Welcome to Computer Vision Streams. We continue with integration of YOLO object detection model to DeepStream, and we try to explore what are the performance optimizations that are available almost out of the box in DeepStream. In this video, we will see how to prepare quantized int8 model of YOLO. So here, in this example, we see that we can expect more than 2 times improvement for YOLO 11 model on the Jetson device. And let's see what will be the improvement on my desktop GPU. So for that, in the previous video that you can check out here, we have seen that going from floating point 32 to floating point 16, we almost double the number of FPS. Let's see how many FPS we will have with int8 model. And let's also visualize it to see that we will lose some accuracy in predictions. So here we see that our int8 model produces 130 FPS. And that is mainly due to a bottleneck of the visualization. And you can notice that we have much less detections that we have for floating point 32 and floating point 16 model, as we have seen in the previous video, and that is due lower accuracy. We will see what are the sources of this accuracy drop. So before that, let's avoid visualizing predictions and see what could be the maximum FPS for integer model. So here we are seeing 275 FPS if we avoid unnecessary visualization. If you compare this model with FP32, you see that we have almost tripled the number of frames per second. But the drawback is that we have less accuracy. And depending on the task, this drop in accuracy could be very considerable, so your model stops being good enough for your use case. But that's the discussion for another video. Let's see what is quantization and how it is performed and which actions we should do. The idea of quantization is that instead of performing all the operations and having all the weights in our neural network in floating points, we will only perform operations on integers, which are much faster and could profit of some additional accelerations. But in order to do that, we need to consider the output of the layers, of different layers of our neural network. And we, from floating point 32, which is very continuous in comparison to int8, we will need to do this transformation from floating point 32 to int8. And actually we have very limited number of values, which is 256 for integer 8, and we need to squeeze all this range of floating point 32 to these 256 values. But the problem is that we would like to be as close to the output values of our model in floating point 32 to approximate it as closer as we can, but we only have 256 values. And for that, there are a couple of methods that could help map floating point 32 to this 256 value to minimize the error. But how we know what are the range of outputs of our model? And for that, we will have to calibrate our model. We will have to take the images of our dataset, of our training dataset, or of our deployment dataset, and verify exactly what were the values in which range are usually the values of our model. And this process is called calibration. And this is exactly the first step that we should do before preparing int8 model. In order to do calibration of our YOLO model from DeepStream YOLO repository, we will have to install OpenCV and compile our library with OpenCV. After that, we can download the dataset that we use to train the model. In our case, it is Coco dataset. Unzip it, create the calibration folder, and choose for the calibration 500 or more images from this dataset. Afterwards, we need to define a couple of environment variables, and then we can create a new configuration file. In this configuration file, it's important to have uncommented engine create function name, which is NVIDIA's infer YOLO CUDA engine get. This is a custom function that will first prepare the calibration table for our model, and next it will generate the int8 engine. Also, we need to choose the network mode of quantized model. This process of creating calibration table could take quite a while depending on the number of images, and after the calibration table is ready, the model will be able to create our engine, and we will be able to run the pipeline. This calibration process helps us to minimize the accuracy loss due to conversion from floating point 32 to int8, and this might be an additional complexity in the creation of our model. Usually I advise to use floating point 16, that is very cheap, and the accuracy trade-off is very in favor in always using half precision models. But for int8, we try to use this optimization only when necessary. Object detection that might require an additional research project to correctly maintain and collect the calibration dataset to maintain the accuracy, but you will receive much higher frames per second. I hope that was helpful. Like this video, subscribe and share, and I will see you in the next episodes.